This video will examine division and how we should be teaching it to students in grades 2, 3 and 4. Initial representations of division need to link visuals with stories and numbers. Here we have an example. Julie has 6 diamonds. These diamonds could be shared between her 3 friends. How many diamonds would each friend get? So we can see Julie has 6 diamonds. We could arrange those diamonds into 3 groups of 2 diamonds, so each of her friends would get 2 diamonds each. The second step with division is to link division to arrays. The concept of arrays should have been taught in multiplication before you get to division. An example of this would be, how can we arrange 12 into arrays? We could do it with a 12 by 1 array, a 1 by 12 array, a 6 by 2 array, and a 2 by 6 array. We could also do it by a 3 by 4 array or a 4 by 3 array. And what this means is that 12 can be divided evenly by 12, 6, 4, 3, 2 and 1. Division, the concept, now needs to be extended by introducing the idea of sharing with leftovers. Here we have 7 bears. We're going to share these 7 bears between 3 people. We want to know how many bears does each person get. So we can see that the first person gets 2 bears. The second person gets 2 bears. The third person gets 2 bears, and there's 1 bear left over. If we were putting this as a division sum, we'd write that 7, how many 3s, or sometimes said shared between 3, would be 2, with a remainder or a leftover of 1. When we're extending this concept further, from leftover to then remainder to then a fraction, we'd write it as 7, how many 3s equals 2 1/3. Once the concept of remainder has been introduced, we need to then show that division can be written in a number of different ways. In our first example, we've got 35, how many 7s, which equals 5. Students have to realise that this representation of division is exactly the same as the one below, which says how many 7s are in 35. Again, our answer is 5. Students have to be exposed to both of these representations for division. All representations embedded with our students, we can then introduce the rule for division. The rule for division is a little bit more complicated in some ways than addition, subtraction and multiplication. Division is the only rule where we work from left to right. So with our 895 how many 8s, we'd start with the hundreds column. So we'd do 8, how many 8s is 1. We'd place our 1 up above our sum and move on to the tens column. We'd do 9, how many 8s is 1 with a remainder of 1. We put this 1 in front of our final number, which is our 5, to make 15. We then do 15, how many 8s is 1 with a remainder of 7. So the way that we'd write the answer to our sum is 895 divided by 8 equals 111 remainder 7. But some of our grade 6s will be able to write it as a fraction, so 895 divided by 8 would be 111 and 7/8. The division concept can then be supported again by estimation and calculator use. It's great to say, well, 895 divided by 8, we'd expect an answer a bit bigger than 100, and that's certainly what we got. Calculator use should only be used to check answers. It shouldn't be used for students to get answers to one-digit division. Finally, the division concept can be extended to decimal fractions. Sometimes this happens in grade 6, but often it's left to year 7 and 8.